Good morning, everybody. Thank you very much for taking the time to listen in to this little webinar. My name is Tor Erik Djupos, or Ted, as most people call me. I'm here today with my colleague, Mariana Copsida, and together we will take you through this little presentation about a new product we have, which is called Trimble SiteVision. We put together a little agenda, and it looks like this. So we're first going to go through and talk a little bit about what exactly is SiteVision. We're going to have a look at the product itself and what actually in it, and then we will touch on what type of data you can use with SiteVision and some of the workflows that you follow in order to utilize and use the SiteVision. And then we will have spend quite some time on the various application areas. So where can you use SiteVision? Some of use cases. We have some videos to take you through, so all of you can get a better understanding of what it is actually you see when you're out there. And then in the end, a little bit of a summary. And at the end, feel free to ask some questions. So I believe all of you have access to a little chat window. We are quite a lot of people in here, so if you can tap in your questions there, we will have a look at this. But anyway, we're capturing all the questions, so we will have a good go through them, and we can get back to each one of you at a later stage to answer any question that we cannot do. So first of all, what is SiteVision? So many of you probably have seen this device, this little handheld device that with a phone on that you can take and go out and look at. So I assume most of you have a reasonable understanding of what SiteVision is. But what we will do here today is go into a little bit more of the details around what SiteVision is and how SiteVision work as a system product for you to use. We say that SiteVision is a high accuracy outdoor visualization tool for spatial data. It certainly is a tool to be used outside, and it gives you that capability to blend in the digital data with the real world data. So you can basically see what you see on the screen here today, where you have a digital formation of something, and you can blend that into the real world. And this again will give you a quite unique and a quite exciting new prospect on how to interact and how to use data for various type of things. And with this, you will then have a number of different controls in order to enhance and blend and control the data that's in there. One of the things that makes SiteVision as good and stable as it is that because we integrate it in with a high accuracy GNSS receiver. So we're utilizing a new technology that we in Trimble have created, which is something called Trimble Catalyst, which is a software GNSS receiver. So by integrating the RTK or the high accuracy GNSS bit into the augmented reality, we're achieving a couple of very important things. One is to keep the model very stable where it should be, and the other is a really, really good orientation. So one of the things that you will see when you then go out, you will see a model sitting very, very precisely where it is supposed to be, but it also sits very accurately where it needs to do. So it's not only using the camera tracking for the positioning of the data itself. In terms of the data that you utilize, the data itself is very much similarity data that you're already producing for a lot of your day-to-day stuff. So, for example, something you can see on the drawing here, that is a 2D drawing. The SiteVision stuff, of course, would need 3D data. When you go out there, you use your own eyes and you view things. You will always view a thing in a 3D world, and this is also what you will do with the SiteVision. One of the key benefit here, of course, is the interpretation of the data gives you a completely new and quite exciting prospect of how the data is being seen there. So again, historically, you might take a 2D drawing with you out, but it's still a paper. Or you might take a tablet with you and have a digital copy of it, but it's still something that you only see in the digital world. By taking that data into SiteVision, you will straight away get a very different experience of that same data, because you straight away can see it in its right environment, where it is and how it is. So the understanding and the interpretation of the data for a user, hopefully, is a lot easier to basically see where and how that data is put in place. However, it's not only about the visualization of the data itself. We can also interact with the information that sits in the data. So any data that contain things like attribute information or feature and attribute information, you can actually access while you're looking at it. So in this example, you have some pipe data or underground utility data, and by basically picking the particular pipe, you can get up a lot of the metadata that actually in that particular model, and then you can interact with it in that way. We can also model some of the viewing of this data based on that attribute information. So whereas sometimes you might just have a CAD line that has feature and attribute in it, we can then go in and say that this CAD line is supposed to be something that looks like a pipe, or this CAD line is something that's supposed to be 2 meters underground. And then we can go in and we can kind of make it look like that. And then together with various viewing techniques, such as the pit view, you will get a quite exciting perspective on how you look at this data as you go forward. Another quite exciting thing with SiteVision is that it's not just a 3D model that is kind of glued onto your screen. It is actually a model that it's placed where it's supposed to be, and you can interact with it by walking in it, around it, under it, so you can view your model from any perspective that you choose to do. This will give it a quite exciting new way of seeing data, because you can interact with it in a very different way. And as we go through some of these use cases, you will see and hear how that interaction can be quite exciting for anybody that's looking at using it. Now, we do say that SiteVision is a visualization tool, but it also do have some functionality for actually collecting data. Currently, we have what we call 5 different modes, and this sits under the application button. So in the middle of the screen, you have a little square, and then by pressing that application button, you get access to some measuring function or some action functions in terms of collecting data. The functions we currently have is what we call a to-do, the capability of measure a point, the capability of measure cut and fill, to measure grade, and also to measure distance. And we will touch a little bit on each one of those in terms of what they do. The first one is what we call a to-do. A to-do is basically a function, whereas you, as the SiteVision operator, walk around and you see something, and you see something of interest that you would like to capture. By then pressing the to-do button, you will take it and capture a georeference picture with or where the SiteVision kit currently is pointing. You will then have the model for what you see, as well as the real life what you see, capture. And you can put in a little bit of a description, put some priorities, the type and so on, and date and these things. But more importantly, you can assign it to somebody. So as part of setting up SiteVision and where it resides, you can create groups and users and so on and so on. So by using this, you can then be in the field and you can assign a particular to-do to a person. Instantly, an email will go to that person. he can open it and he will see the particular to-do and can then action that particular information as where it is. The pictures are georeferenced, which again means that you can add this into a GIS, a map GIS, and so on, so you can see where they are and where they sit. In terms of the measuring modes and the function for doing or capturing data, we currently have 3 modes. This is the GNSS mode, which means that you can capture GNSS points from basically underneath the antenna. So you have the capability to put on a survey pole, put in something like a name, a code, a pole height. The SiteVision kit also comes with a little built-in EDM. So by going through a little setup procedure, you can aim it at something, it will have a red laser dot, and you can do what we call discrete points or offset points. And by aiming at a particular physical object, you can then take a measurement and you can get a point or a position coming out of that. It also has what we call an AR mode. This is basically measuring to a model itself, and I will look a little bit more on that. The functions you can do with these modes is I can measure a point, I can measure cut fill, and I can measure grade. And I can do that with each of the different modes. So for example, a point can be done with a GNSS or it can be done with the EDM offset. The AR bit means that if you have a 3D model sitting somewhere and let's say there's a steel beam and you're 10 meters away from it, you can aim at it and you can actually measure that point aimed at that steel beam model in itself. And the same goes with the other ones. In terms of a cut fill, that is measured over a surface. So if you have a TTM model and you're walking over it, you can then shoot either GNSS points or DR mode, and it will give you a cut fill value as you do these measurements and go along. And last but not least, grade. So this is a 2-point measurement function. So you measure 1, you measure 2, and then you will have the line and the grade for that system. And with the combination, you can also get some comparisons. So you can measure real world to model, model to model, but also real world to real world in order to get various type of information that you want to do. Now, when you measure this information, it's stored into the SiteVision system. And as you do that, you also have the capability to send that data back. And we store it basically in a CSV file, which basically contain all the information that you have captured, such as the lat and long, if you're using a local coordinate systems, orientation values, and so on and so on. So you have full interaction with that. Something that is quite new is that in order to view data in a more exciting way and a better way, we've created a little desktop application that's called a SiteVision Visualization Manager. And this is basically a tool where you can create or create rule set for using 3D models to the data you capture. So if you have a feature code library that has number of features and the features have number of attributes, you might want to assign certain things to this particular feature. So for example, if you're capturing a tree, then you have a 3D model for that tree, or if you're capturing a fire hydrant, then you want a 3D model for that. A light pole, you want a 3D model for that, and so on and so on. So by setting up your rules library to match with your code, GIS code library, when SiteVision is processing these data, it will also view these data. So instead of maybe just using a CAD file that can be sometimes a bit boring just to look at because it's just a line, you can get the data to come to life in a much more exciting way of seeing data. This can be used for various things in terms of how it's being displayed for the user. In terms of the components that SiteVision currently contain is what we see here. First of all, we have the little integrated hardware. It's a handheld device. It has a battery that can be put up into the handheld that will power the device itself, and it will also trickle charge the phone that's connected to it. It has the built-in EDM that you'll see on the top there. This is basically the laser shooter. Integrated with the handheld is the Trimble Catalyst antenna that sits on top, and it's an integrated part of the system. In terms of the GNSS receiver itself, this is something that's actually incorporated into the SiteVision application. So we're using something we call a software GNSS, which is basically incorporated into the application, and it's then sitting in there. The application can be downloaded from the Google Store, installed onto the phone together with a couple of other key components, and then you run it. And last but not least, SiteVision is utilizing a very standard display. So today we're using a Android mobile phone system. And the reason for that is we're using the Google AR Core bit for the AI side of things. So you can use a standard mobile phone. Now there is certain phones you can use and certain phones you can't use. But I will always say that, as these mobile phones has progressed in terms of development, the later phones by far is much, much better. So the performance, for example, between a Galaxy X7 and a Galaxy S10 Plus for the visualization and how lines, for example, are being projected into the depth side of it, has come a long way. So as these phones expand and get better, you also get much, much better performance on it. Currently, it has to be an Android 9 or an Android 10 system for it. So some of the key features for the SiteVision system, as we described, very accurately display 3D data in a real-world context. It utilizes the Trimble Catalyst software GNSS receiver for centimeter accurate. So it's same technology that we're using for the survey grade that gives you a few centimeters accuracy of the positioning. We are using the Google AR Core technology. This is the component that Google is creating for the augmented reality systems. So this is the technology that we are fusing our high accuracy position into in order to get the position placed very accurately. We're also using Trimble correction service. So things like Trimble VRS now is part of the SiteVision system. So the correctors you need in order to get that high accuracy functionality into it. But you also have the capability to add in your own correctors if you want to do that. And as we also have tried to do, it is compatible with a wide range of different data formats, and we'll go through a little bit of these ones. Not only Trimble one, but also open industry standard file formats to get in there. We're utilizing something called Trimble Connect, which is a cloud-based service, and this is the kind of holding ground or the staging ground of the data. But Trimble Connect is more than just that. It is a collaboration platform that we in Trimble are using for a lot of our data. So this is a place that you can upload data, share data, collaborate with data, and it can use a lot of different formats for interaction with users. And this is part of also the SiteVision, and it kind of goes into ecosystem and how we handle data. And last but not least, the measurement modes, the capability of using the EDM. You can measure various points, the GNSS, and the various functions and modes for taking these measurements. A little bit before we start looking at some of the use cases in terms of how the data for the SiteVision system flows. So the tools you're using for capturing and creating the data that's being used in SiteVision is pretty much the same as you would do for any other traditional digital data capture on the model side. You would either use GNSS receivers, total stations, laser scanners, these type of things, and you will then process the data in the typical field office softwares that you use for doing that. We then storing the data into the cloud in the Trimble Connect platform. And as I said in my previous slide, this is not just about holding the data, it is also about where you can interact and use the data among other stakeholders. And then when you run the SiteVision system, it is basically downloading the data from Connect and you're visualizing and using it. And if you're collecting data, it goes back there, which can then be distributed back again. In terms of data formats, we do believe we have so far a number of open industry standard formats. So things like land XML, IFC, a number of the Autodesk such as DWG, DXF, S3 shape, images, TTM models, and so on are all files that can be used. So as we know, these can be generated from a number of industry standard packages, that be S3, Bentley, Autodesk, and so on and so on. We also have some of our own internal format, so SketchUp, the modeling software, Trimble Business Center, a Trimble's construction and survey centric package for survey and construction data. Connected maps, T-maps, Vision Link for construction friends, and so on and so on. So it should be quite a number of different formats that can be used for this. And again, the data, when it's done, it basically goes on to Trimble Connect, where it sits and go through a little bit of a processing, and then you can take it up and view it in the SiteVision system, and you can report back to it. Okay, that was a little bit from me and a little bit about what SiteVision is and some of the data formats. I'm going to hand it over to my colleague, Mariana, and she will take you through some of the use cases and some of the applications and how to use SiteVision in a bit more visual than we've gone through so far.
Thank you very much, Ted. So Ted explained a little bit of what SiteVision is, what kind of functionalities SiteVision supports. So together we will go through the use cases, how SiteVision can be used in the field, how you can interact with the data. So that might give you some ideas of how you can use it in your workflows too. So we explained that by utilizing such technology, you can have your spatial data at the real environment at the right time. That means that you can improve collaboration either in the field with other participants there or among different stakeholders from far away. With the additional functionalities that SiteVision supports, such as the measurements or the to-dos, we can also facilitate reporting process. So all the data can be there, and we kind of facilitate the near real-time communication between the field and the office. So better data interpretation, better collaboration, better reporting, that can also mean better decision making. That, of course, can have a big impact in our projects. For example, by having the right data, the right environment, it makes it easier to reduce errors in the process, to identify errors quite early in the construction process, or to identify that something in the design model doesn't seem correct. That can have an impact either in the schedule, so we can shorten schedules, or at least we don't have to have many overruns. We can improve quality because better data means also better quality, and then can have also impact in the risk and the cost, the overall cost of the project. So SiteVision, it's a standalone tool, but can also be complementary, as Ted explained, with the workflows. And the main areas that we can see SiteVision being used are those four. So first of all, you can see the hidden, for example, underground facilities, either, for example, for installation purposes of pipes, so you can check if the pipe is installed at the right place, or how the installation process goes, or where you need to dig something, but also for safety reasons. If I have roadworks, I might want to avoid some pipes in the street so I can see that. I can see the future, so above ground structures, how the new development can impact the environment, or how my project will look like. And we will see some examples of this. We can also use it very nicely for earthworks and see the progress by utilizing maybe the cut and fill functionality that Ted described. And also it's a really nice tool to visualize boundaries, either for cadastral or, for example, on construction sites. It's quite important to update the safety paths, and that can be a really nice tool because all these safety paths are updated all the time. So it's a nice tool to inform in a better way the workers there. So let's see some uh, examples of all these different use cases. I'm sure you can think of additional use cases, or you're working in an industry with spatial data. Um, SiteVision can visualize any spatial data, so you can use in many ways, but we will see the main industries here. So we explained before that you can visualize utilities in a nice way. It's not about uh, cut lines or spheres, but with the visualization manager, you can actually visualize and display 3D objects, which makes the whole data interpretation much easier and more intuitive. You can also see here that we can visualize above ground facilities, that we can also assess how this can fit in the environment, what kind of impact will that have in the area. There are some additional tools that helps with the visualization. Again, it has to do with better data interpretation. So you can either make the object opaque or not, but also we explain that you have all the metadata with you. It's not about displaying 3D object, but it's also about accessing the right information at the right place. So in many cases, because you have this 3D data at the right environment, it's easier to understand if something is missing or not. So you can take measurements as well, as you can see here, or record offsets. This is a demonstration of the real to real measurement. So we measure a point in the real world and another point again in the real world. And this information goes back to Trimble Connect, as we explained, and anybody at the office can have instant access of it. Another industry that is quite interested in such tool, because anyway we create, we interact, we consume 3D information, is architecture. So by utilizing again SiteVision, we can display our building at the right environment, we can assess it from different perspectives. And by utilizing layers, we can help again with the visualization, hence with the data interpretation. We can use the 2D view, which makes us understand where we stand relative to the building. And by having the 3D data in the right form, in one-to-one scale at the right environment, it's just easier to review, for example, here, the interior design. We can check if the windows are placed correctly, or if the views are okay from there. And if I want to change the views, or I want to change something there in the building. But also it's about checking material specifications, which makes again the whole decision making much easier. Here it's a demonstration of the real to model measurement. So you can also measure side details and check offsets, or if you want to place your building in a different position. But also by utilizing the to-dos, you can share views with clients that further away, or with other colleagues in the office or other stakeholders. If you notice that you want to change something, you can just write something that it fits or it doesn't fit and report back. It's not only about new developments, though. It's also about maintenance or wanting to change something in the house. Here you see an example of changing the front view. So I can use it either as the contractor or as a customer. So I can check different options for my house with different materials. But if I have different data and I can communicate the different data to the customer, and here you can see even how the trees will check with time. So I have that kind of control with my data. And again, it's just different to see the data on 2D screen and understand how that will fit in the real environment. And it's just different if I see it at the right environment, where I can go and check it from any perspective, or I can check the data the way I want. Another big industry is the building construction. Here you can see how a structural model with the MEP is visualized. And because I have this 3D data in the right environment, and because I can see it from any perspective, it's easier for me to identify any classes, and I can create specific tasks, as you can see here, where I can assign to a specific person. I can assign a specific type or description. So again, it makes the whole collaboration between the field and the office much easier. And of course, we as explained, it's easier to identify any classes or errors, or just perform the inspection in a much more efficient way. Here you can see some examples of a current construction where we have aligned the data to the real environment. So I can check if my columns are the right place, or if my columns are the right shape, or it makes the whole building construction more intuitive because it makes the workers more proactive, because I know what will be built where. So I shouldn't put some scrap, for example, in this area. But it also facilitates the whole construction process in general, because I can check if I have done my prior works correctly, so the works that come later on can fit properly. That can be with any installation process, and check if the data that will come will fit properly in the environment. Here it's another demonstration of a big project. So again, I can go with my clients and display to them how a bridge will look like, or what this bridge will look like in the future and the impact that will have, or if the construction process is going forward in the right way. Another use case is the urban transportation. So you can see here how we can uh, visualize a new design of a road and compare it with the existing road. I can also check all the service details by utilizing here the cross-section functionality. But again, as we explained, you can visualize the data from any directions, so you can assess the design in a much better way. And of course, it's a really nice tool for public engagement, because we can see how the new development will impact the area. So it's a really nice tool for the local authorities to have when they want to demonstrate to people in the area how this new development will look like and what kind of impact will that have in the area. Here you see an example of civil construction, and for linear construction. You can check grades by utilizing the additional functionalities. You can read your virtual stakes with all the data that sits in there. You can check cut and fill and then issue work constructions, as you can see here. So it's a really nice tool that you can also capture the mixed reality photo with the attributes within it, and have that as in order to facilitate reporting. You can send measurements to the office, so anybody that have noticed an error can immediately um, um, change that or edit that. You can verify construction against design. This is a really nice example of how the model looks like compared to the real construction. And of course, you can estimate the work that needs to be done in order to be assigned as complete. Last but not least, we explained that it's also a really nice tool to locate and communicate boundaries, either for cadastral or to visualize any additional paths or boundaries that your workflow requires. So that was a summary of different use cases, but also what SiteVision is. So we explained that it's a very high accuracy visualization tool for spatial data. It's mainly an outdoors tool because it also utilizes the GNSS readings. It runs currently only on Android phones, and as we explained, the better the phone, the better your data, and the better interaction that you have, bigger size of models. But you saw that it can be used in many, many industries, and as a complementary on the standalone tool. So I will be curious to maybe if you can give some feedback or some ideas about how you would like to use SiteVision, maybe some challenges or some benefits that you will have. But now we're also, I will also answer any questions that you might have. So thank you. Do we have
Thank
any
you.
questions so far?
I am not sure if we do. Thank you very much, Mariana, for that. So as you say, feel free to tap in any questions that you may have, and we will be happy to have a look at it. I will also say, as I say, there is quite a lot of people in here at listening to it, and coming from many different places in the world. If this is a technology that you find interesting, and if this is a technology you're interesting to maybe have a little bit of a demonstration, to see a little bit more, feel free to get in touch with your local Trimble distributor, whether that is somebody that's doing our building sides, our heavy civil sides, the traditional geospatial users, anything like that. They should all be able to help. And if you have any questions about that, then yeah, absolutely feel free to contact them for more information.
Then, Mariana, we have a couple of questions that came in the questions box. Can see them. We can go through them.
Mm-hmm.
So
go ahead then.
I don't think I can see them, Ronald.
Okay, so one of the first questions is what position is stored with the image antenna position, I assume. Would it be possible to measure a point and attach a photo?
If it be possible to measure a point and attach a photo afterwards.
Yes, I assume so.
So first of all, in the position that is stored within the image should be the GNSS, yes, but also probably orientation. And if you can measure a point and attach a photo, you can measure a point, then you can click on the point, and in this point you will have some attributes. That will be the information. So once you click on the point, you will see the attributes, and then you can click on the to-do and save the image. So yes, with a workaround workflow.
Okay, thank you. Another question was about the workflow with Trimble Quadri. Are you able to comment on that?
Actually, I don't know what is Trimble Quadri.
Oh yeah, no. So Trimble Quadri is a database from the Nova Point system. I don't have too much information on where they are with that. I know our friends in Vianova has been looking at that, but that's something that we need to catch up with them to get a better understanding of where we are. We have all these questions down, so we can look at that.
Okay. The next question was the use case you showed for architecture, the building. What model format did that come from?
And that should be a SketchUp model.
Okay.
For buildings, a really nice format to use is either SketchUp or an IFC, or if it's a structural model, you can use a Tekla model, export it as an IFC. But that specific one, I think it's either IFC or SketchUp.
Okay. Okay. What about changing floors if we want to investigate a whole building?
If you want to investigate that, it's either you have different models with different floors that you want to visualize, or within the same model, you assign different layers for different for different floors. And then from the layers functionality, for the layers button, you can hide and unhide different floors, so you can check it that way. The same way that kind of we saw with the trees in that use case, in a similar way.
Mm-hmm. All right, thank you. Another question or comment, I guess more was somebody experiencing quite slow uploading issues with Trimble Connect.
Just one also comment from for the previous question. I suppose maybe that person means that they want to change not the floor in the first floor, but also need to navigate to the second floor or the third floor. I think that should be tricky unless they position the building a bit lower, or they are able to go on the second floor. So you are not allowed to change floors physically if you cannot climb stairs. This is what I mean.
Mm-hmm. Yeah. So somebody was also asking whether you would, for instance, be able to download some of the project data directly to the phone rather than go via Connect. But Connect is the way to go, right?
Yes, at the moment you need to upload your data on Trimble Connect because there is a backend process on Trimble Connect that converts the files into a Trimbeam format, which is an optimization kind of format for visualization purposes.
Yeah.
But we also have a desktop version of Trimble Connect, or which is called a desktop version of Trimble Connect, where you can upload and download the data, and within there you have an direct export function to change it to the Trimbeam format. So it's a way to go if you want to get the data through a bit quicker.
Mm-hmm. Similar question as before for the architecture use case, the structure model example, what kind of model source was used there, or what format was used?
So
It should
as
be an
Mariana
IFC.
said, yeah, SketchUp, IFC, but you can also use DWGs if they're surfaced DWGs, but quite often the IFC models are very nice, the SketchUp models are very nice, and these type of things. So depending on what you want to see, the different models, the different file formats are good for different things. So IFCs, SketchUps, to some degree DWGs is quite good for the structural side of things. In terms of open formats, of course, we can also use things like Teklas and our own formats on that. In terms of underground utilities, land XML, shape files, these because they're quite good at containing attribute information that you can use for other things. So depending a little bit what you want to utilize will also dictate a little bit what format that's good to use.
Mm-hmm. Okay. Then there's also a question whether we could use a larger screen, for instance, using an Android tablet.
So the challenge with that is dictated by what we call the Google AR Core component. Currently, as far as we know, that is a component that only loads into the mobile phones. It doesn't load onto the current tablets. That's the first thing. So if it isn't a component that sits on the tablets, it's difficult to use. Like the other thing right now, in terms of the SiteVision bracket, it's a bit difficult to get a whole tablet attached to that one in a practical way together with the GNSS antenna. We have some specific offset we're using in order to position it quite accurately. in terms of where the antenna, center of the antenna is relative to the cameras and so on and so on.
Mm-hmm. There's also a question that's more related to the correction services, I guess. So can I connect to my VRS network?
You can. So if you are connected, first of all, within what we call the Trimble VRS Now umbrella, the correctors is part of that particular umbrella side of things. However, in the SiteVision application, you can turn that one off. And when you do that, you will then get the capability to log on to any N-trip connections at your will, whether that is a VRS network or if you set up a single base system, that can also be done.
And I guess the follow-up question there was that do I need to make a correction subscription with Trimble also?
You can use any correction service that is available. Whether you have your own single base station, you just need to get the corrections over the internet system. There's no radio connection connected to it, so you can use your own single base if you have that, or you can use another supplier's VRS correction if you choose to do that too. We're using standard CMR3s, and in the Trimble side of things like CMR, CMRXs, and stuff like
that. Let's see. Can you mount a Revit drawing, say Revit MEP, in a building model?
If you can, I didn't quite understand it.
A Revit drawing. So
a Revit drawing
in a building model.
So I am not sure that. So we cannot read Revit models native Revit models. I'm not quite sure that they are open formats. But if you export that native Revit model into an IFC or something like that, then we can use it.
There's a lot of different questions here, so I'm just quickly looking through that. If models are textured, will the texture be displayed in SiteVision?
Yes.
If I import a 3D model from SketchUp Pro and I'm looking for under roof designing, then how much accuracy it gives?
So the important thing is where you are. As I say, SiteVision today is an outdoor tool, outdoor visualization tool. So you need to be in a place where you can basically get GNSS cover and stuff like that. But as long as you're out and you have a model that represents a house and you're inside, that doesn't matter. You're still outside. But to take SiteVision inside into a building, you can still use SiteVision inside. But in that case, you have to place the model manually. There's a process for that, and it works. But since you're not using the GNSS, you're only reliant on the camera tracking. So the model will move more. It will jump around a little bit more. It won't be as accurate simply because the camera tracking isn't as accurate.
Mm-hmm. There are a couple of questions around that, around the accuracy to be achieved. Is there anything else you want to say on that? So
we're utilizing traditional RTK technology. So similar type of accuracies you get down to what the surveyor is using for. But of course, GNSS accuracies is sometimes a relative thing. So if I say, your position accuracy within maybe, plus minus 50 mil, 3, 4, 5 centimeters, you're probably in a good place.
Okay, thank you. That's also an interesting question, how SiteVision compares to the Trimble XR10.
So Both utilize, let's say, augmented reality, mixed reality. So it's about visualization, right? SiteVision, though, it's designed for outdoors environments, and XR10 is mainly designed for indoor environments. So both are very good, but for the right environment. So they are not competitive, they're complementary. So if you want to visualize 3D data that are outdoors, you need to use SiteVision for accuracy. If you want to visualize data within a building or in vertical construction that you're under a roof that people mentioned here, maybe the best tool for that will be the XR10.
Mm-hmm.
They very much complement each other as two technologies.
Can we upload a GGN file format?
Actually, you can. Yes, you can do GGN. I think we have a little bit. I think we have some bugs we need to sort out there, but we can use DGN files too. There's yeah.
Okay. Is it possible to customize the data collection interface?
Not at this moment in time. We have no SDK to SiteVision. It is what it is.
The only way you can do it maybe is through the visualization manager. So once you capture some data, if you use, for example, Terraform or other GIS systems that you capture a specific tree, for example, instead of having a sphere, you can use the visualization manager. Since you have assigned it as a tree, then you will also be able to visualize it as a tree.
Another one, if we have 3D line string drawing for utility networks like electric lines, do we need to convert 3D line to utility network first and export to SiteVision, or can we do it from SiteVision Visualization Manager?
So it depends a little bit. So we basically take a one of the standard formats. I don't know what format your data is in, but let's say it's in a shape format. Then you can take that pretty much right into SiteVision as it is. If you want the data to look different, we need to start looking at the attributes, feature and attribute information you might have in that data in order to create that other visualization. If there is no such thing, they will simply show up as lines. If your data isn't in what I would call kind of a standard format, shape is a very international format. Well, it's a ESRI format, but it's widely used. XML is another one. If your data isn't in any of these or standardized CAD, you need to convert it to something that we can use to get it up there.
Another interesting one is, can you display large 3D geophysical survey data, for instance, 2 kilometers in size?
Are we talking about going down into geophysical? Are we talking about going down into the ground? If I understand the question, I understand the question correct. This is something we actually in the process of trying out with a couple of clients, but due to the current restrictions on movement, we haven't really had a chance to it. So I've received some data from people we're working with on some geophysical data that we want to try to visualize. So something we'll probably have to come back to a bit with more information.
Yeah, it was indeed for going down into the ground.
Yeah.
Also a question on whether we could just show point clouds from laser scanners.
Not at this moment in time.
All right, well, there's a lot of other questions. We'll see how we can still address it, but we're running out of time here now. So I think we have to close it for now, but we'll try to come back to other questions as well and reach out to people. One last question that's popped up a few times here is around the cost for the system. Since we have a lot of people from different parts of the world working with different currencies, my first recommendation would always be to reach out to your local Trimble distributor. And other than that, I would say thank you very much to Ted and Mariana for doing this presentation, and thanks everyone for joining today. And we're looking forward to see you again on one of our other upcoming webinars.
Okay, thank you very much for attending.
Thank you.